Velocity, position and acceleration from graph. On the graph are shown position, velocity and acceleration functions of an object. Explain their relation algebraically. So this is another question from my series of understanding position, velocity and acceleration relation. Now earlier we have already done this question where we found the answer graphically, and now let's prove it algebraically. Now we know there are three different graphs and derivative of one can be related with the other by finding how the turning points are represented. Now the first graph, which is A, has a turning point at 4. Now that means we should have derivative should have 0 at this point, and the function which has derivative is c. Therefore we can write that c is derivative of a, right? So that is, we can write a dash. Now if you analyze b, then we have two turning points here, and at these turning points zeros are for a. So for these turning points we have zeros at a, right? So this turning point corresponds to 2 and this corresponds to 6. So at the turning point a is 0, and therefore we can say that a is derivative of b. That also implies that b should be position vector, a should be velocity, and c is acceleration, right? So let me start with now writing equations for each. So we now know that b corresponds to position vector. Okay, so b corresponds to position. Now if b is position, what is the equation of b? Let's find out the equation for b, and then from there we will find equations for velocity and acceleration. Since they are the derivatives, we can find the equations, right? And then check whether the graphs really corresponds to them or not. Now for b, we have two zeros. One is at 0 itself, the other one is at 6. The 0 at 6 actually is a double zero since the graph turns. So we can write function b, which we are saying is displacement, as a function of time, which we have written x, but I wrote t here. Let me continue with t now. Okay, now it should be, okay, let's make it x, right? So there's not much confusion. So it's a s, we are calling this graph as s of x. Let's write down the equation for displacement with respect to time, which is x. It has two zeros. One is at 0 itself, the other one is at 6. Now 0 at 0 is linear, the other one is quadratic. So we can write this as x times x minus 6 whole square. Now we really don't know which family of curve should fit into this. So we write a parameter, and let's say the parameter is k. To find k, we'll use the point given to us, which is 232. 2 is the x value, 32 is the y value, or s of x. So we get 32 equals 2k times, and the x value is 2. K times 2, 2 minus 6 whole square. Now let's simplify this. So we get what? 2 times minus 6. 2 times 2 minus 6 square will give us 2 minus 6 is 4, 4 square is 16, and 2 times 16 will give us 32, right? So we get 32k. Now that implies that k is equals to 1. So we get the value of k from here. So if k is 1, we can write down s of x as equals to x times x minus 6 whole square. So that is our function. Now it's a good idea to write it in the expanded form. So we get x times x squared minus 12x plus 36, which is x cubed minus 12x squared plus 36x. Indeed, it's a cubic equation, and it is represented rightly as a cubic equation. So we finally got the equation for displacement vector. right? And now let's figure out if s of x is equal to x cubed minus 12x squared plus 36x, what should be the velocity? Velocity is derivative of displacement, right? So we can have derivative of this function. We get what? We get 3x squared minus 24x plus 36. This we can factor 3 x squared minus, if you divide by 3 you get 8x plus 12. And now we get 3 times product of two numbers should be 12 and the difference or the sum should be minus 8. So the two numbers are 2 and 6, both negative, right? So we get x minus 2 times x minus 6. And truly that is the graph with two intercepts at 2 and 6. Perfect, right? If you put the value 4, you will get the minimum also, right? So you can find that position. Well, let's move on and find the equation for the acceleration, which is represented by c. So acceleration is equals to derivative of velocity, right? Velocity, we will use the very first equation, is easiest to differentiate. So let's differentiate with respect to x. What do we get? We get 6x minus 24. So 6x minus 24, that means this point should be minus 24 and the slope should be 6. Well, we can also verify with the x-intercept. If I put 0, if I put 4 for x, I get 0 for a, right? So the x-intercept is indeed at 4. So that verifies algebraically that these curves are represented by the given equations. So we get our equations, which are s of x equals to x cubed minus 12x squared plus 36x. Velocity function is derivative of this, which is 3x squared minus 24x plus 36, and the acceleration is 6x minus 24. And the related graphs are already shown to you. I hope this exercise helps you to understand how do we get equations from the graph, how are they related, and how to figure out which one belongs to which. I hope you appreciate it. Thank you.